In the last lecture, we discussed Get Mechanical Engineering 2022 set to paper 2 question. In this class, we discuss the remaining question of Get 2022 set to paper. So, in this class, up to this question we discuss, and from this class we discuss this question. So, given Wien's law is stated as follow: lambda t is equal to constant, where C is 2898 micrometer Kelvin, and lambda m is the wavelength at which the emissive power of black body is maximum for a given temperature T, and the spectral emissivity epsilon lambda of a surface is shown in figure, where 1 angstrom is 10 to the minus 10 meter. The temperature at which the total hemispherical emissivity will be highest at what Kelvin. So given lambda t is equal to constant, where constant is 2898 micrometer Kelvin. So we have to found the temperature, where 2898 micrometer Kelvin divided by lambda m. So the epsilon lambda is maximum at lambda m is equal to 6000 angstrom. So lambda m is equal to 6000 into 10 to the power minus 10 angstrom means 10 to the minus 10 meter. It is equal to 6000 into 10 to the power minus 6 meter divided by 10 to the power 4, which is equal to 0.6. 10 to the minus 6 is micrometer. So putting this value in this equation is equal to 2898 divided by 0.6 micrometer, and 2898 micrometer Kelvin, per unit micrometer cancel, and 2898 divided by 0.6 is 4830 Kelvin. Which is the option D is the correct answer. And this is question for radiation heat transfer. Next question: a linear elastic structure under plane stress condition is subjected to two sets of loading 1 and 2. The resulting state of stress at point corresponding to these two loading are shown in figure below. If these two sets of loading are applied simultaneously, then the net normal component stress sigma xx is equal to what? So this resulting will produce this angle theta equal to 45 degree. So given sigma x is equal to 0 and sigma y is equal to sigma, and tau xy is shear stress is equal to 0, and theta is equal to, it is clockwise, so taking a negative, minus 45 degree. So sigma xx is equal to sigma theta plus sigma, and sigma theta we know sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos 2 theta plus tau xy sin 2 theta. So sigma x is equal to 0 and sigma y is equal to sigma. This is 0 and this is sigma, and theta is minus 45 degree, and tau xy is equal to 0. So this is equal to sigma by 2 plus minus sigma by 2 cos minus 90 plus 0, which is equal to, this is also 0 and this is equal to sigma by 2. So sigma x is equal to sigma theta is equal to sigma by 2 plus sigma is equal to 3 sigma by 2. So option A is the correct answer. Next question. A rigid body in the xy plane consisting of 2 point mass 1 kg each attached to the end of 2 massless rod. This is the massless rod. Each of length 1 centimeter. This rod length is 1 centimeter, as shown in figure. If the rotation rotate at 30 rpm counterclockwise, this is counterclockwise above z-axis. This is the z-axis towards the perpendicular to the skein, passing through the point O. The point mass of root 2 kg is attached to one end of third mass rod. It is used for balancing the rod by attaching the free end the rod at point O. The length of the third row is dash centimeter. So this is 90 degree to each other, and we have to attach one mass, one point mass, which is the balancing purpose. Is weight is root 2 kg, and we have to find this length, this balancing mass, and this is the balancing mass name is MB, and the distance at which balancing mass present from the point O is RB. So given data is M1 is equal to 1 kg. This is M1. This is M2. And R1 and R2. This is R1 and this is R2. 1 is equal to R2 is equal to 1 centimeter, and balancing mass MB is equal to root 2 kg. So we know the from balancing equation MB RB square is equal to M1 R1 square plus M2 R2 square. Sorry. So putting the value of MB, M1, R1, R2. So MB is root 2 and RB we have to found square is equal to 1 into 1 square plus 1 into 1 square. This is 1 square is equal to 1 plus 1 square is equal to 1 is equal to 2, and root 2 square is 2 into RB. So RB is equal to 1 centimeter, which is option A is the correct answer. Next question. A tube of uniform diameter D is immersed in a steady flow in viscid liquid stream of velocity v as shown in the figure. Gravitational acceleration is represented by g, and the volume flow rate through the tube is. So this is the point 1, and this is 0.2. Now apply Bernoulli equation between 1 and 2. So Bernoulli equation is P1 by rho g plus V1 square divided by 2g plus Z1 is equal to P2 by rho g plus V2 square divided by 2g plus Z2, and head loss is 0 as it is in viscous liquid stream. So P1 we know P1 is P atmosphere plus rho g H1. This is P atmosphere plus this is the depth H1, so this is rho g H1 divided by rho g, and this is V1 square divided by 2g, and taking the reference this side, so Z1 is equal to 0, and P2 is P atmosphere as it open from the atmosphere, so P2 is equal to P atmosphere divided by rho g plus V2 is also we have to found V1 is equal to V2, so V2 is taken at V2 square divided by 2g plus Z2 is H1 plus H2. So P atmosphere by rho g and P atmosphere by rho g it's cancel, and this rho g H1 rho g H1 this is also cancel, so V1 square divided by 2g, and remaining this H1 and this H1 also cancel is equal to this V2 square divided by 2g plus H2. So V2 square divided by 2g is equal to V1 square by 2g minus H2. We have to find volume flow rate. So V2 is equal to V1 square minus 2g H2 root over so volume flow rate Q is equal to area and velocity. Area is pi by 4 d square, and the V2 is V1 square minus 2g H2 whole root over. So answer will be pi by 4 d square b square minus 2g H2, where V1 is equal to V and 2g H2. Option D is the correct answer. Next question. In a vapor compression refrigeration cycle, the refrigerant enters the compressor in saturated vapor state at evaporator pressure with specific enthalpy 250 kJ per kg, and the exit the compressor is superheated at condenser pressure with specific enthalpy equal to 300 kJ per kg. At the condenser exit, the refrigerant is throttled to evaporator pressure. Coefficient of performance of the cycle is 3, and specific enthalpy of saturated liquid at the evaporator pressure is 50 kJ per kg. Then the dryness function, the refrigerator at entry of evaporator is what? So given data, COP of the cycle is given 3. Let us draw the pH diagram. This is anticyclic pH. This is 1, 2, 3, 4. Given specific enthalpy at the saturated vapor at the evaporator pressure, which is equal to H1 given 250 kilojoule per kg, and the exit of compressor, this is the exit of compressor at the condenser pressure, specific enthalpy equal to 300 kilojoule per kg. At the condenser exit, refrigerant throttle to the evaporator pressure. So the condenser exit throttle to vapor. Okay. The specific enthalpy of saturated liquid at the evaporator pressure is 50. So this is 50 kilojoule per kg. And we have to find the dryness fraction of the refrigerant entry to the evaporator. We have to find the dryness fraction. So given COP is 3, and the COP we know refrigeration effect divided by work input equal to 3, and refrigeration effect is, this is the evaporator, is equal to H1 minus H4, and the work input is equal to compressor work, which is equal to H2 minus H1 equal to 3. So we know the value of H1, H4, H2, H1, and we simply putting this value, sorry, this T kilojoule per kg, we have to for dryness fraction value at the specific enthalpy at the saturated liquid at the evaporator pressure. So this must be some value we have to find the dryness fraction. So we don't know the H4 H3 value. So we found from this equation where H1 is equal to 250 minus H4 we have to found, and H2 is 300 minus H1 is 250 is equal to 3. So 250 minus H4 is equal to 3 into 300 minus 250 is equal to 50 into 3 is equal to 150. So H4 is equal to 250 minus 150 is equal to 100 kilojoule per kg. So we have to found HFG, which is equal to 250 minus 50, 50 at the pressure enthalpy at the liquid evaporator pressure, which is equal to 200 kilojoule per kg, and this 200 we have to found using this equation and dryness fraction equation. So we know H4 is equal to HF plus X HFG. So Even HFG is equal to 200, as HFG is equal to 200, and X value we have to calculate it, and HF is equal to given 50, and H4 equal to 100. From this H4 get, so H4 is equal to 100 is equal to 50 plus X into 200. So we get 50 is equal to X into 200, implies that X is equal to 50 by 200 is equal to 1 by 4, which is equal to 0.25. Dryness fraction is 0.25. Then next question. The best size wire is fitted in a group of metric screw such that the wire touches the flank of the thread on the pitch line as shown in figure. The pitch P and included angle of the thread are 4 mm and 60 degrees and 60 degree respectively. Diameter of best size wire is dash mm, round up to 2 decimal. So given data, pitch is 4 mm and thread angle, this is thread angle, given 2 theta is equal to 60 degree. So semi thread angle we have to know, and theta is equal to 30 degree. So diameter for best size wire is equal to, diameter is equal to P by 2 sec theta. So pitch is 4 divided by 2 and sec 30. So calculating this, we get 2.039, which is equal to 2.031 mm. Option B is the correct answer. So that's all for all question. One more question from GATE 2022 set 2 paper. In the next class we try to solve 2021 set 1. So thank you.